Picture this: Philippine transpose system. Polluted air in the city, honks everywhere, traffic, crowded, rush hour for every day. When will this bust and hustle get any better? Well, lucky us because the light rail trains just got lighter with aluminum. This 2023, the Light Railway Transit Line 1 or LRT1 added a new set of aluminum trains to its fleet. Funded by Japan, it followed the 2-year inspection since it arrived in 2021. In this episode of Metallica, we will figure out the MATSE and beyond behind lighter rail trains, the advent of aluminum in the Philippine metro rail systems. Now, what's the fuss with aluminum all about? Aluminum is an abundant silvery white element, making up over 8% of the Earth's core mass. As the fifth most mineralized country in the world, the Philippines houses rich mineral resources, including bauxite, from which aluminum is commonly mined and extracted. Now, just a glimpse of its extraction process: a crushed bauxite has varying degrees of purity, but aluminum in the form of hydroxide or oxide is the largest constituent. Undergoing the Bayer process, aluminum oxide dissolves in the hot, concentrated sodium hydroxide solution. The other impurities are filtered out of the mixture as sludge. Next, aluminum hydroxide is precipitated from the filtrate by the addition of pure crystals to induce the process of precipitation. The precipitate is filtered, washed, dried, and heated to 1100 degrees Celsius to get alumina for smelting or electrolytic reduction. Then, in the whole Herald process, the alumina is electrolyzed at 950 degrees Celsius in a molten solution of various elements. The aluminum metal is collected at the cathode and the oxygen gas at the anode. Finally, the end product of aluminum extraction can either be the pure metal itself or alloyed to attain the desired properties, and it can undergo casting or extrusion depending on applications. Some of the general properties of aluminum include its non-toxicity, corrosion resistance, high thermal conductivity, malleability, and ductility. For these reasons, aluminum is used largely in commercials for electronic devices, pipes, and scaffolding usually seen around construction zones. It is also found in the limelight of households, such as food packaging, the beloved foil and soda cans, kitchenware, and even appliances such as refrigerators and air conditioners. The transportation industry, specifically LRT1 trains, also benefit from these properties of aluminum. Its primary advantageous properties, aside from the ones mentioned, are high strength-to-weight ratio. High-strength aluminum alloys such as 6061 and 6005A is commonly used for the construction of the car body of the light rail transit. The former is stronger but more expensive than the latter. However, a study confirmed that the high 0.62% total deformation of 6061 compared to the moderate 0.41% of 6005A was deemed insignificant due to the favorable price of the latter. Formability. The incorporation of wrought aluminum alloy into the LRT train is cost-efficient due to it being easier to manufacture as well as not requiring a lot of parts. The most well-known metros that use aluminum alloys are Japan's Shinkansen bullet trains, Canada's LRC, and France's TGV duplex trains. Earlier, 7003 profiles for the floor, side place, and roof of the car body in Japan were employed, but issues regarding its difficulty on extrusion and stress corrosion were prominent. It was then replaced with 6005 alloys to have better extrusion, welding, and corrosion properties to produce porous complex hollow profiles with thin walls. The primary alloyed elements in 6005 include silicon, which improves toughness, manganese, zinc, and titanium in varying degrees to increase hardenability and machinability. Copper and chromium are often added to promote corrosion resistance due to the passivating layer that reduces the reactivity of aluminum alloys to chemical surroundings. Therefore, the most common aluminum alloy employed in the vehicle body of LRT is the 6005A, since it has a great balance of cost efficiency, strength, machinability, and corrosion resistance. It has been employed in the general structure of trains, particularly for the sidewalls, end walls, underframes, beam columns, and roofs. Low density. The wide usage of aluminum alloy in trains is due to its lightweight property that helps in reducing the overall weight of a vehicle, critical for its performance and fuel efficiency. Having a density of 1/3 of steel, it takes significantly less time to decelerate and accelerate an aluminum train per stop. Hence, the time it takes to commute is significantly lessened. In the case study of LRT1 in Philippines with many stations and very minimal distances in between, less energy would be required to use the machine of an aluminum train periodically, proving its increased fuel efficiency. Overall, due to its resource-intensive extraction procedure, aluminum is one of the most expensive metals to produce. Though the high cost of aluminum initially raises the cost of producing vehicles, ultimately, aluminum alloys increase allowable transport capacity to the extent most favorable for all stakeholders. In industry, the cost-efficient way of producing aluminum body trains is beneficial for manufacturing companies, and in the economy, more customer turnout due to efficient trains hastens the cash flow. In the environment, a step toward the greener use of manufacturing and application is also a step toward sustainable and equitable development. Ultimately, in our society here in the Philippines, the increased satisfaction of citizens with the Philippine transportation system in the form of LRT1 promotes a healthier sense of livelihood. Thus, when considering the overall advantages using aluminum body trains in the Philippine metro rail systems, the lighter rail trains is more favorable for us in the long run. And that's it from this session of Metallica. See you again, commuter!